Hello my friends, welcome back. My name is Maltanen, and in this tutorial I'm going to show you the new 3D camera tracker in After Effects CS6. Now, you might have seen my YouTube tutorial about this subject, which I released the second that CS6 was announced, and I didn't really talk about the 3D camera tracking in general. I just showed you what the new 3D camera tracker allows you to do in terms of creative solutions, but I didn't really talk about how to approach the 3D tracking in general. So this is what we're gonna do today. I've got a couple of different footage examples prepared, so we're gonna start with something you can follow along. So basically we're gonna do the same footage. We're going to use the same footage I used on the YouTube tutorial. However, we're going to focus more about proper 3D tracking, which I did not focus in the tutorial on YouTube. So to follow along, you can just go to hollywoodcamerawork.us and go into the download sections, and in the green screen plates and in the tracking plates you will find some nice footage that you can use along with this tutorial. So just go ahead, look up this footage and download it, and you can work along with me. So let's just start. As in the YouTube tutorial, you saw me apply the new 3D camera tracker onto the footage, and that was pretty much it. We just give it a couple of seconds. By the way, it's amazing how fast and accurate this 3D tracker was. This 3D tracker is, even though it's fully automatic. However, what I did there was not entirely proper in terms of keeping things mathematically accurate. What a 3D tracker expects is that there are some points, high contrast points in the footage that the tracker will find and track in 2D. And then when the 2D tracking is done, it just compares the movement of all the points to figure out the 3D movement of the camera. And the conditions in which this can only happen properly is that the points that are being tracked are not moving. And even though in this footage it seems like everything is okay, we know that the actress in the shot cannot stand perfectly still. It's just physically impossible. And that alone can cause some problems, at least from the mathematical point of view, and elegant solutions. So let's just go ahead to the advanced tab and see how the average error turned out to be. Now it's 1.01 pixels. And in theory, whenever you get a lower error than 1 pixel, you can consider that to be a solid track. But of course, the lower the number, the better. And sometimes, of course, it's a little bit different. Sometimes the average error may even go above 2 pixels, and in some very specific cases, it can still work as a good track. And I'm going to show you that later on in this tutorial. But for now, we know that the actress is not staying perfectly still. That's just not possible. So in order to fix that, we're going to use a couple of tricks. The thing I didn't mention in the YouTube tutorial is that how to isolate some areas from tracking. And the easiest way to do that is to basically make some areas of the footage transparent. That's at least my approach to it. So we're going to do that now. I'm just going to pre-compose this and call this footage. It's just the thing of mine. Usually I just, when I don't know what I'm going to do with the footage, I usually just close it down into its own comp in order to pre-comp it again and again if I need to. So right now I'm going to isolate the actress, and I'm going to do that using either the mask, but we know that's not the way I would do things, right? Because we would have to animate the mask and so on and so forth. Actually, in this case, we could probably just draw an oval mask around her and just go ahead and subtract it and, hope that it's going to be okay and just animate it slightly. But then again, this only works in this specific case, right? Because this is a shot that was made with motion tracking in mind, right? That was intended for this shot. And in this case, since the actress is not moving, it's pretty easy to animate the mask. But I rather like more universal approaches, and that's what I'm going to show you in this case. We all know the amazing roto brush tool, which was introduced in After Effects CS6. And if we click on the footage, we can basically just make an outline of our object of interest. However, this tends to take some time, and actually in this case we don't need to be that accurate. So in order to make this process faster, I'm just going to do something that Rotobrush tells us never to do, which is I'm going to lower the quality of our footage. So I'm going to move to quarter resolution, and now I'm going to apply Rotobrush. So I just make sure that the Rotobrush tool is selected. I double click on the footage. I'm going to find a good frame here, maybe something like this. I'm just going to zoom in a little bit, use the Control key to adjust my brush size, and I'm just going to draw a rough outline. As you can see, this should work perfectly. I'm just going to make sure that I have both legs, including the shoes, because things like that in lower resolution tend to stay out of the selection sometimes. So I think that's okay, and I'm just gonna expand the propagation span and just move forward. Just take a look how blazing fast that is, and I'm gonna see how this went on. I think we can maybe do a little bit of adjustment in here. Okay, and let's just try this as well, and maybe just adjust it a little bit. As you can see, lowering the quality tends to bring up some holes and tears in our roto, but I guess, you know, it's pretty easy to fix that, so it really depends on the case you're working on. So that's totally up to you to use quarter resolution, maybe half resolution, whatever works for you. So I'm going to move back and see how that works. Okay, I think that's gonna be just fine for now. We can subtract this area right now, and we don't have to worry that we had the area between the legs basically selected before. We don't really care about that. Okay, this looks good. I think that just subtracting this bit and this bit on, of course adding the legs, is going to produce a better mat. And yeah, just for the sake of it, I think we're gonna leave it like that. Maybe just subtract a little bit, and okay, we're gonna say that's good. As you can see, like I said, Rotobrush tells us draw Rotobrush strokes at full resolution. This is something that Rotobrush will always tell you to do, but in this case we just moved to quarter resolution. And I think this is actually looking quite good, so I'm going to freeze the solution, and I'm going to use this to extract her from the shot. As you know, at this point, what we have is just the actress in the room. We don't, and this is something that we don't want. We want actually the inverse of that. So I'm going to use the invert filter and set the channel to alpha, and that way I've got just the room. Even though we've got some movement in the roto brush mask, it doesn't really bother the 3D tracker. But I'm going to smooth that out anyway. So I'm going to use simple choker before applying the invert filter. I'm going to just expand this a little bit, and I think this is going to work just fine. So right now I'm going to pre-compose this, and I'm going to call this key. I'm going to move all attributes, and this is what I'm actually going to track. So let's just go ahead and apply 3D camera tracker and just give it a couple of seconds to process the footage. Of course, this is analyzing in background, so if there was something we could do during this time, we could freely go to another composition or even stay in this composition and continue working, maybe designing the elements we would like to incorporate to this. But since we don't have that case, we're just gonna let it do its thing. So right now, let's take a look at the advanced options. And as you can see, the average error dropped down to 0.8, and I think that's pretty decent. So the very common question that I get is, do we have to get rid of all those junk, lights, monitors, all those stuff from the shot before we track? And the answer is, as long as they're not moving, the more junk, the better, because they give the 3D tracker more points to track, more contrast points to track. Just take a look at this green screen. Those tracking points in here are, of course, contrasty enough and green enough to be keyed out, but there might be cases where this could not be enough. So adding things in the background that do not overlap and will basically not cause any keying problems is a very good approach to do a 3D camera tracking. So as you can see, we've got all of this junk, and we also have this little marker in here, and you can tell that the tracking is pretty solid by the size of the tracking points. I'm just gonna increase them just a little bit. It of course doesn't change the tracking, it just changes the visual representation of what we've done, and you can tell by the size of the tracker that these are actually closer to the camera than the ones on the wall, for example. And I think we have a pretty solid track right now. So what we're going to do now is we're going to add a floor. This is something that I usually do in this type of shots. So I'm just going to pick a bunch of tracking points on the ground floor. As you can see, After Effects even suggests which points are good for that. But then again, the more points, the better. So I'm going to select all the points that are on the ground, that I know that are on the ground, and I'm going to use those to generate my ground plane. And I think this will be just fine. I can, of course, move the bullseye target indicator to move around the floor and see if it really sticks, and it seems that it does. So I'm going to position the target right where she's standing. Oops, I lost my selection, my bad. And then when that's done, I'm just going to right click and create null and camera. And right now, as you will see, the null will stick exactly where it should be. So it marks the point where the actress is standing. This is something that I like to call relative positioning. So I always have things positioned in relation to some other things that are important in the shot, for example. So having that done, we can now move to our key composition and basically invert the whole keying process. So I'm going to go in here and uncheck invert, and now I have a very nice garbage mat around our actress. So what I can do is just apply key light, and we're not going to focus on doing a nice key. I'm just going to pull a very dirty key very quickly and just maybe shrink it a little bit using screen mat options and just clip the whites and clip the blacks a little bit. So we can really see that she's there. We're not going to worry about the quality of the key right now. So having that done, we now have our actress keyed out in a transparent space. So how do we put her in a 3D environment? Well, the easiest way to do that is just to create a new solid layer. Size of the composition, that's totally okay. I'm going to make it black. Click OK, and I'm going to apply a grid effect to it. And with blending mode set to normal, maybe we're gonna do it with the width slider, so we can have a regular grid like that, and click on the 3D switch. And now I'm going to use a new parenting option in CS6, which is parenting holding shift key. I can also hold the alt key, but I just kind of like using the shift key in this case because it moves and transforms my child layer to the parented layer. As you can see, the position right now is zeroed out, and I can move transforming the layer from this point on. So I'm just gonna use the scale and move the layer below, and now you can tell that she's really standing in this 3D environment. To make this look a little bit more interesting, I'm just going to import something that I have prepared earlier on, and this should be it. Okay, and this is a 3D room that I built way before 3D was available in After Effects. I mean the extrusion 3D. This was actually built in CS2, I believe. So there's no trickery to this. I get asked about this a lot. It's just a bunch of flat layers positioned in 3D space. So I'm just going to take this room and put it as an environment to this footage. So I'm going to turn off the grid layer and just put the room in here. Of course, I'm going to turn the 3D switch on and collapse transformations. Remember that this room is made of 3D layers, so in order to use it in another composition, I need to collapse it if I want to have the whole 3D layers react to the camera that I have in this composition. So as you can see, the room is positioned quite bad actually. So what we can do is use again the same new parenting method. So I'm gonna just parent it to the track null holding the shift key, and you can see that now the room is more or less where it's supposed to be. We can of course move the camera and see how that works, and yeah, we can tell that it does work, but it's oriented in the wrong way. So I'm just going to rotate it 90 degrees, and basically I can now just scale it up, and we can tell that she's really inside of this room, but she's floating in midair. So what can we do about this? Well, this is again something that I called relative positioning, and this is a topic that I will discuss heavily in my upcoming training called Creative Breakdowns. It's not yet available, but check out my Facebook and multanen.com for more info about that. So I'm just gonna do this very quickly and just create a new null object, make it 3D, basically parent everything to it. And of course I wouldn't have to do that if this was built with relative positioning in mind. So that should be it. And now, yep, now she stands right at the floor. And take a look at this. Actually, right now, this is one of the cases where 3D parameters for the scale actually make sense, because I'm sure when you had like a text layer and you scaled it in 3D, you had this additional parameter for the Z scale, which did nothing, right? But when you've got collapsed layers, it actually makes a lot of sense. So take a look at this. I'm going to unlink the proportional uniform scaling, and now I can just stretch the room in Z. I can stretch the room in Y. I actually want to make it I want to make the seating a little bit lower, but I want to make the room wider. So like that, and maybe wider on this axis as well. Okay, and that makes a lot of sense. We've got a little bit of a problem here. Okay, now that's gone. And I think that this actually looks pretty good. Okay, if you want to see how to add text to this, you can go and watch the YouTube tutorial. But what I want to focus in this tutorial is dealing with shots that were not meant to be motion tracked and matched move like this one. But before we move there, I'm going to show you another example of a shot that was built to be match moved. So I'm going to load this clip in, and again, you might have seen this on my Facebook fan page. This is from the project called Culture Counts, and I have the before and after video in there. So if you don't know what I'm talking about, just go ahead and watch that. This is what we have, and as you can see, this is a perfect shot to demonstrate the very principles of proper match moving, so proper 3D camera tracking. So I'm just going to apply the 3D tracking, 3D camera tracker again, and you will see how crucial it is to exclude all the moving points that are in the shot. This is the best example and my favorite example that I use all over the time when I do training about motion tracking. So let's just give 3D camera tracker a second to track this footage. And now that it's done, we can just take a look how the tracking went. Well, it looks like it's pretty good when we just kind of look at it, but if we take a look at the advanced options, we can see that the average error is 2.04, which is quite huge for this type of shot. How do I know that? When we look at the shot, we can kind of sense what's going on with the camera. So we can assume that this should be pretty easy to solve, but having an error of 2 pixels for a shot we can understand and assume that it should be easy to solve is quite big. But here's the trick. We are very good at understanding what's going on in the footage, right? So we look at a piece of footage and we kind of sense and we understand that we have a boy in here, there's a wall behind him, there are 2 stands in between, and that the camera is kind of moving up. We know that, but the computer does not. And what the computer sees are just these points. So in order to do a proper 3D tracking and to shoot a proper tracking footage that is meant to be tracked, you have to look at the footage with your dumbest eye, with just basically scrapping everything that you know and that you take for granted and just look at certain points. To demonstrate that, I'm going to just key him out really quickly. I'm going to leave the 3D camera tracker in here because we're going to need it later on. But I'm just going to key him out really quickly. So I'm going to use the roto brush tool again and of course move to quarter resolution and basically just paint over him like that. Okay, we can subtract this area in here, and yeah, let's just leave it like that and just expand the propagation span and just move here, give him a couple of seconds to process that. Okay, and just move to the end as well, and we can now freeze the solution. It's pretty safe that it went all okay. We don't need to check that. Yeah, so once the solution is freezed, just take a look at this. If I would create a green plate behind him, something like that, we would have no clue how the camera moved. Well, maybe we would, because we can kind of tell that the camera is moving up, but it's not very precise, right? If we would like to put something behind him and just kind of eyeball it, there would be probably a lot of sliding, things not keeping their positions in 3D, so it would be kind of hard. Of course, we could maybe track it in 2D and have some pretty decent results, but this tutorial is about 3D tracking and the advantages of 3D tracking over 2D tracking, which is something that we'll get to later on in the next example. So when we look at this, we can't really tell what's going on, right? But if we would to invert it like we did before and just leave everything else in the footage, I'm just going to maybe change the color of this green to match everything else more or less, and add simple choker to this as well, like that. Now when we look at the static and non-moving points, we can perfectly understand what's going on. As you can see, this marking point is right at the same level where the boy is. Then we've got another one a little bit further back, and then we've got those tracking markers on the very wall behind him. And by the way, funny story. this footage was shot because it was supposed to take place in the art gallery that we couldn't really close down to shoot this scene, so kind of just shot it with a DSLR, you know, guerrilla style, shooting from under our arms and from the bags and everything. So we just took a bunch of photos and composited a background that was going to be placed behind him when we track this. So when we look at this footage, we can really understand what's going on. And actually, the computer sees even less than this. So let me just show you what the computer sees, and then we're gonna move forward. So this is basically what the computer sees when we look at it. It seems like the camera is moving, but we know when we look at the footage that it's not the camera moving, it's the boy moving. So as you can see, it causes these markers and all the area kind of shift left and right, and this is what's causing this 2.04 error. So I'm just going to turn everything off. We've got the camera tracked already. I'm gonna turn the footage back on, and I'm gonna show you another way of fixing the track. Of course, like in the previous example, we could have just roto brushed the actor and do that, but sometimes it's easier to just kind of select the points that are causing the problem and just delete them and watch how the average error will go down when I do that. And the great part about this is that the shot does not need to be tracked again. It's just being solved again with those points ignored. So now it's down to 1.1 and we can move to the earlier parts of the footage and delete those points as well. And now it's gonna drop down even more, maybe. Yep, 1.13. Let's take a look here. And as you can see, After Effects is clever enough to understand that, okay, we had some markers in this area in this point in time. You deleted them, so I'm gonna look in some other areas, ignoring the area that I was focusing on before. So let's just move forward, and we can see that the new marker points show up. So let's just delete those as well. Down to 0.9, which is quite okay, but we can do better than that. We're gonna delete those. 0.8, and we're gonna delete those. 0.6, and that is a pretty good track. We can get rid of this point in here as well. Maybe that will solve some of the problems, but I think this is a pretty good track, and we can see that those points are no longer sliding on the surface. So let's just take a look if they're static. Yes, they are. And before, as you can see, the boy moves here left and right. That was causing the problem, and those markers were basically shifting and moving all over the place. So having the average error down to 0.6, I think this is a pretty solid track. So we can now select the points in the background, which are the points that interest me the most. And I'm just gonna position this somewhere around here and click Create Null and Camera. Actually, I don't know which camera is the proper one, so I'm just gonna do that again. Select the tracker, select the tracking markers like that. Move it here and create null and camera. Okay, that's good. So now what I can do is to import the image that was made as the background plate for this shot. I'm just gonna drop it in. I can get rid of this solid. I'm gonna turn it to a 3D layer, and of course I'm gonna key out our actor. So to do that, I'm just gonna pre-compose him and leave all attributes in this composition. I'm gonna call this footage, and I'm gonna pre-compose it again and call it key. And now I'm gonna go inside the key composition and again use the roto brush tool. And of course I'm gonna drop the quality down to quarter. Okay, it's already set to quarter, that's good. So I'm just gonna double click it and really quickly draw an outline, and I think that's gonna be just fine. can get rid of this area in here. And yep, I think that's gonna be just fine. So I'm gonna move to the beginning of the composition and to the end of the composition, let the roto brush do its thing. And now that we're done, I'm gonna freeze the solution and close the footage layer, and I can really see that this is looking pretty good. So I'm going to use the simple choker, expand the selection just a little bit, and then use my key light again to key out the green. So let's just do that. Maybe let's choose a different portion, maybe this one, and see how that looks. Okay, that seems to be a little bit better. We've got a little bit of noise on his face, and I've already covered how to get rid of that in the tutorial on MotionWorks from the After Effects A to Z effects series, and the effect discussed was the channel combiner. So go ahead and look for that either on MotionWorks or on my YouTube channel. So we're not going to worry about that right now. So we're just going to go back to this, and as you can see, I've got my shot already done thanks to the layer that I brought in earlier. But right now we can tell that something is very, very wrong, and that is because this layer is not yet positioned correctly. So I'm just going to use again the new parenting option and just parent it to the null that was created from the trackers on the back wall. And I'm just gonna scale it up, and now that seems to work just fine. And I think I can even move it up a little bit so I can have this light above his head. Maybe just move it right a tiny bit. And here's a fun trick. The way you can use the 3D tracker is not only to put in like 3D layers, you can also apply effects that are only 2D and then use a small expression to move them into the 3D space, which is something that I'm gonna do right now. So I'm going to create a new solid and just make it black. I'm going to call it 2D flare. Of course, lens flares. Yes, we're gonna add lens flares. So flare, I'm just gonna put it in, and as you can see, this is a 2D effect, and even if I'm gonna put it into a 3D space, this is not going to work as expected, because even if I would position this correctly in 3D space, the flare itself would be static, and what we want is for the flare to move in order for all those rings to move along. So this layer should stay as a two-dimensional layer, and just the position of the flare center should be driven from the three-dimensional position in our 3D space, according and relative to the camera. So how do we do that? I'm going to turn this layer off for now, and I'm going to duplicate this tracking null, and I'm going to call this 3D flare position, and I'm just going to pick a frame that looks good where I can see the light above, and I'm just going to position this where I want it. And as you can see, this will stick to that place accordingly, because we have this tracked in 3D space. And now I can just simply alt click on the flare center and use the pick whip to point to the 3D flare position, and I'm going to write 2 comp and 0, 0, 0. This is a magical expression that takes a three-dimensional position relative to the camera and calculates its 2D position on the screen. So having that done, we can really see that those 2 points match exactly. This is our 3D flare, and this is where the lens flare is putting the flare center. So take a look at this. This is exactly what we wanted, right? So having that done, we can now just change the blending mode to maybe add or screen, whatever suits you, and we can change the type of the lens, maybe to, oh no, I think I like the 50 to 300 millimeter better. Okay, and that's how you do it, basically. So I hope you got the general understanding of how to do a proper match moving shot, keeping all that things in mind and how to track it properly. But now let's move to something that was never intended to be motion tracked. And this is something that I really like to do. We are all used to seeing, amazing examples on the demo sessions of, software, basically. But don't you have this feeling that whenever you try to do something, things don't work out as good as they did on the demo? And that happens sometimes. Demos are designed to show off what the new capabilities of the software are, not necessarily how to deal with problems if they occur. So that's totally understandable. So now I'm just taking a shot that was never, ever intended to be motion tracked. And as you can see, there's a lot of moving points. We have a huge movement of the camera, and this is actually just a small part of a 3-minute movie that was shot using just one shot, right? This was all directed, choreographed, and this was just a one long 3-minute shot with the camera moving through multiple rooms, going upstairs and such. So there's a lot of things moving in here, and the camera is all wiggly, and especially this guy. This guy can ruin even the best shot, right? I'm not talking about specifically this guy, but basically anyone who's moving across the shot will cause all tracking points basically to be swapped away and moved away. So this is a very dangerous case. And actually, there's a video on YouTube that shows this. It's like my favorite video processing geek joke ever. If you're gonna type optic flow detection gone wrong on YouTube, you're gonna find the video, and this is the video I'm referring to. Just take a look at this. It's hilarious. Gets me every time. Okay, so let's just go back to After Effects and just try to track this shot. And here's a little tip. If you expect some problems in given areas, you can just trim the footage like this and then apply the 3D tracking camera, and it will only treat this part of the footage. And when you're done, you can of course expand it, and the camera will not be solved for the expanded areas. But if you need the footage, you can just then expand it. So I'm just going to ignore this very first couple of frames, which are totally black, because it causes this tracker to think a little bit longer, but I assure you it does solve the thing. Or you know what, actually no, I'm just gonna apply it like that and just edit out the part when it solves it. So I'm gonna put it in, we're gonna see how long it's gonna take him. Let's see, it's 400 frames, we've got 5% already, and we should get an estimate, like 1 minute. Okay, so I'm gonna just take a break for 1 minute and get back to you when it's done, which is now. And as you can see, at the beginning of the shot, we've got unable to solve camera for this frame, but then as soon as anything goes into the shot, we've got the camera solved. So let's take a look at the average error. It's 1.6, which is surprisingly low for this type of shot. And I remind you, this is a fully automated process. And this is the first time that I've seen any automated 3D camera tracker do a solve that good on this type of a shot. Honestly, most of the trackers I've tried would basically collapse and give up on this shot. And most of them are really expensive, and they even have the manual tracking, which would be the only solution to solve this shot. And you would have to basically just pick a point here maybe and track that, and oh, it's out of the frame, so you'd have to find another one and another one. You would constantly have to try new things, and it would take probably about maybe an hour to find the proper points that stay in frame long enough for the camera tracker to solve this. But in After Effects, the built-in 3D camera tracker is just amazing. It's really amazing, and it produces really great results. And you know what? I'm not even gonna bother with deleting the moving points, because overall shakiness of this footage, I think it kind of helps. So let's just take a look. Oh, and yeah, here's the guy that swipes all the tracking points. This is something that may be a little bit counterintuitive for the first time you see it. And this is why I got asked a lot of questions on the YouTube video that I did. Why does my not footage track correctly? Why I do get the unable to solve error? So just take a look at this. We've got some points in this area, and the guy just runs through and swipes them away. And now you've got those points again. But as far as After Effects is concerned, those are different points. So it's not aware that these are the same points that were here before. So this may potentially cause a lot of problems depending on how the camera is moving. So let's just take a look at the overall track. I think this wall helps a lot. See, because we've got a lot of points that we would not pick by hand when looking at this. We would thought that they may not track correctly, but the automatic tracker just finds whatever it thinks it can stick to as long as possible, and that saves this shot. And this is only, I've seen this only in 3D camera tracker built in After Effects CS6. So thumbs up to the After Effects developer team. Okay, so what can we do? I mentioned that in some cases the high average error does not cause that many problems, and this is the case. And the second thing I mentioned we're going to talk about is something that makes the 3D camera tracking superior to any other type of tracking. Right now, we've got the real 3D camera moving through a virtual space. And thanks to that, we can put anything in that space in any place in that space. For example, if I would like this guy that runs through the shot, just run like that, and maybe bump into a sign or something that would hang in midair, I could not do that using any other tracking solution, because there's nothing to track. It's just thin air. If we would track something in this area, we would essentially track the wall that is back there, which is not what we want to do. And the 3D camera tracking did track this wall, but it also tracked this area and this area, and it figured out the 3D movement. Therefore, I can place something in 3D. So I'm just going to do that now. I'm going to put a sign right here, a sign that maybe someone from the prop department forgot to bring into the set or whatever. So let's just pick some points that we can use to put something, put a sign in this area. As you can see, we don't have many points on the table in here, so we're just gonna have to work with what the automated process gave us. So I'm just gonna look very closely to find some points that share more or less the same three-dimensional plane. And I think that this point will do. This will do, even though it seems it's a little bit higher. See, even we can't tell if this is higher or is it on this same plane that the table is. And that's the same problem that 3D software and 3D camera tracking have when we don't do this properly. So I'm pretty sure that this one sits on the table. Maybe the finger, maybe this, and maybe those on the glass as well. It doesn't seem very good, but maybe, okay, this makes it look a little bit better. So let's just scale down the tracking size and see if this sticks to the table. Okay, it seems like it does, so I guess this is a pretty fair bet that this will work. So I'm just gonna move the tracking, the target size to this position and click create null and camera. And now I'm gonna add a new text layer and just type in bar like that. and I'm gonna make it a 3D layer, and of course parent it using the new parenting, holding down the shift key. And now I can just rotate it like that and just move it up, and right now we can see that this sign basically sticks to where it's supposed to be. But we can see that we could position it a little bit better. So what can we do? We have nothing to track from this point, where we don't really need to, because we do have the plane of the table. So we can now position this in relation to this area that we solved. So I'm just going to rotate it like that and push it in on the Z space, and this should work quite well. I'm just gonna hide all the controls so I can see how that looks. Okay, I think that's quite okay. No, maybe let's just rotate it a little bit like that and maybe push it in just a tiny bit like that, and that should work. Yep. So, and you know, this is fully dynamic, so right now I can just click here and type in happy hour or whatever, right? And this just works. So, you know, 3D camera tracker is not only for VFX supervisors and VFX artists. It can be used in whatever matter you think about it, right? This is a creative tool that allows you to track shots that were previously untrackable, basically, and place things in your shots that could not be placed in there before. So that's basically it for this tutorial. Well, there's one more thing I get asked a lot. How do I export my 3D camera that was solved from After Effects to other 3D software? And I gotta tell you that I'm working on that, even though there are some, you know, semi solutions to that, because there are many plugins that allow exchanging data between software like 3D Studio Max or Blender or Maya. But there's no universal solution that would solve all the problems. And for now, if you're using, for example, Cinema 4D, which you know, it's pretty safe assumption to do when someone's working in After Effects, then the obvious choice of 3D software is usually Cinema 4D due to tight integration with After Effects. If you have that, you can go to Maxon's website and just go into the downloads, and then from the plugins section, you can download the plugins for After Effects CS3 to CS5.5. Which allow you to exchange the data between After Effects and Cinema 4D and the other way around as well. So when you install these plugins, and they also work in CS6, you will get a new option in the export menu, which is Cinema 4D Exporter, which is exactly what I'm going to do right now. So I'm just going to make sure that I've got my composition selected, and I'm going to go to Export, Cinema 4D Exporter. I've got a test scene here, so I'm just going to overwrite it, and I'm going to go back to Cinema and just open it up. So open test C4D, and I should have my camera and my tracking null, and everything seems to be just fine, as you can see. Okay, the ground floor is a little bit off, but we don't really have to worry about that because that's all relative data. So that's how you do it. Now you can just basically put like a background element in here, load your footage here, and position your elements the way you like, render them out, and just bring them back to After Effects if you need to. But just as a reminder, After Effects CS6 has a great extrude feature included right now in CS6. So for example, you can extrude logos and text. So if I would like to give this text some depth, all I would have to do would be just to go into composition settings, turn the new ray traced 3D engine on, and just basically go to the geometry options, and just extrude it the way I like. And that will be it. I could also turn on the reflection intensity to 100, make a duplicate of this layer and make it an environment layer that basically is casting reflections onto our sign. Change the color of the sign to white in this case, and that will be it. Basically, as you can see, it works and it reflects the environment that we're in. And of course, we can focus on the designing 3D text and some other tutorials. So, okay guys, I hope you've enjoyed this extended look at the new 3D camera tracking feature in After Effects CS6. My name is Multanen. Remember to check out my website and my Facebook fan page, where you can find, all sorts of up-to-date informations, maybe some small tutorials that don't end up being on multanen.com. So once again, thanks for watching. Happy After Effecting.